Hey everybody, my name is Jocelyn Ross and I am going to be presenting my paper on marsupial and placental evolution in animals. Go to my presentation. Okay, so I'm just talking mostly about placental and marsupial origins in the mammalian group subclasses. So first off, I wanted to ask a couple of questions and see if you knew what these were. What is a mammal? What are the origins of mammals? So that means when did they originate? What are the three groups of mammals? What are the differences between a placental and a marsupial mammal? And then when and where did the placental and marsupial mammals radiate? And why is it so important for us to understand the radiation of the mammalian kingdom at all? So these are some of the things that I'm going to be discussing during this slideshow, this presentation. So here we go. So first off, I wanted to talk more about time periods. So to the right, you can see the Mesozoic era, and the bullet point states that mammals radiated during the Mesozoic era. This does not mean that we know exactly when mammals came to be mammals, but this is the approximation because there are not as many fossils as we would like, and so the fossil record is very small and limited. So during the Cretaceous period, the non-avian dinosaurs, they went extinct. And so during this time period, this is when you see the boom of the mammals. And for the diversification of mammals, it just like opened up the opportunities for these mammals to fill in the niches that the dinosaurs left. And so if you just see, like during the Cretaceous was about 150 million years ago. And we'll be talking mostly about the Mesozoic era. So in between the 250 million years ago to, what does it say, around 65 million years ago. So if you just keep that in mind while we continue. So we're going to start at the beginning. So mammals originated around 190 to 200 million years ago. And if you see this, let me get a pointer, laser pointer. Okay, so if you see this, other tetrapods, that means kind of reptiles. So they say that we originated from reptiles. And I'm mostly going to talk about the therapsid and mammals. So reptiles, therapsids, and mammals. So what makes a mammal so unique so that you can find it in the fossil record is that you see the separation of the mandible and the ear bone, and there's an expanded brain belt. So if you look down here at this, at the kind of skulls that are drawn there, you will see the differences. So when it talks about the separation of the mandible and the ear bone, so we're talking about this dentary, right? And in the therapsid, which was we talked about a little bit earlier, the therapsid has all of these bones that are kind of connected and bigger, and they're called the jaw joints, right? They're right next to the jaw joints. But as you can see in early mammals, they have gotten a lot smaller. And so these have become the ear bones of the mammals. So when you look in the fossil record, it's really easy to tell if that is a mammal because of the ear bones. There's no ear bones in a therapsid, but there are in the mammals. So it's kind of cool to see that. Also, they talk about dentition a lot. So they're looking specifically for molar dentitions, and they can tell when a mammal radiated due to that dentition. So like what you learned in maybe middle school or whenever, mammals have mammary glands and hair, but you can't really find those in the fossil record. So it's kind of hard to distinguish them if you can't see them. And there's two groups of mammals. There's technically the Therian and the Prototherian groups. So the therian group means that they give live birth. The mammal gives live birth. So placentals and marsupials give live birth. And so they are stuck in the therian group. Prototherians means that they don't give live birth. They lay eggs. And that is where you see monotremes. And then under there, you can see the eutherians, metatherians, and prototherians, because there are three groups of mammals. There are the monotremes, placentals, and the marsupials. And eutherians means that they have a fully functional placental, and that will be used for the placental mammals, of course, and we are placental mammals. And metatherians, it's kind of like suggesting that it's in the middle. So they still have a placental, and but you see it that it's not as developed, and you'll see that in kangaroos or koalas. And those are marsupials, and prototherians, monotremes. So those are the groups that you see. Okay, so this is just a picture showing what we talked about before, that you go from a reptile to a therapsid to a mammal, and that was kind of the evolutionary process of mammals. So in placentals, we talked about them having a placenta before, and that is what defines the eutherian group. The young are more advanced and developed at birth. So you can see some of the attributes. They have metanephric kidneys, lungs that work when they're born, and they have more mobility, and their eyes are usually open, and their ears are usually viable. You can use them. But that doesn't mean that they can live without their parents. They still need the parent to take care of them. So this, because they are so much more advanced at birth, this increases their chances of surviving stochastic events, or events that are not, that you can't, that are unforeseen events, like a meteor or change in climate. And they are also the most abundant mammalian class. And this is probably due to the ability for them to resist the changes and events that happen in life. So marsupials, they also have a placenta, though it is different. The young go to the pouch where they attach to a teat, and that acts like the umbilical cord. So this helps them to grow, but they are so much more underdeveloped than the placentals. This actually places more stress on the young, so it is kind of a harder condition to live by, and that is probably why they have not radiated as much as placental mammals. But one of the cool things about marsupials and placentals, which is why I wanted to study this, is that they are so alike. They have the same ecological and morphological similarities, and it's just so cool to see that evolution can create this again, or recreate it in a different way. So in order to understand placental and marsupial evolution, you need to understand Gondwana and Laurasia. So these are supercontinents. As you can see, Pangaea right here was made up of a bunch of different continents, like all of them put together. And then Laurasia and Gondwana, they split approximately about 150 million years ago. Some scientists give a different number, but that's the one we're going to go with today. And they say that marsupials and placentals radiated on Gondwana land. And so you can see in Laurasia, there are no marsupials found. So it is important for us to understand this, because you can say that they radiated here and that the marsupials stayed on Gondwana, right here. But the placentals moved, and they moved into Laurasia, and that's why you find placentals in Europe and in Asia, but you don't really find marsupials. So it's just kind of important to understand the continent shift here. And then these are all the continents that make up Gondwana and Laurasia that you can see. And yeah, I already kind of explained the Therian group that diverged during that time period of about 150 million years ago. Okay, so to get more in depth into the radiation of mammals, the Theria and Prototheria group diverged around 190 million years ago. So that means that the monotremes right here and the Therian group, so this is the Therian group, they diverged from each other around this time. Okay, so we have not had very much time to diverge, diverge. So it's only 200 million years ago. So at first they thought that Eomaya was the first or one of the closest relatives to the marsupials. So if you look over here, Eomaya, not sure how to really say that. And it diverged around 125 million years ago. But they just recently found Duramae sinensis, and that diverged around 160 million years ago, as you can see right here. And so they originally thought that that placentals and marsupials had diverged about 130 million years ago, but they now know that it's around 166 million years ago because they have to give time for divergence. So Duramae sinensis diverged around 160 million years ago. So it pushed back evolution about 45 million years. And that was a big deal because that's a lot of time. Okay, so convergent evolution. I kind of already talked about this, but if you look to the left and this picture here, you can see that the marsupials and the placentals are very, very similar. They differ in developmental rates and in their skulls, so you can tell what's a marsupial and what's a placental in the fossil record. But if you just look at those, they're so similar, and you can just tell that natural selection is acting on these organisms through their niches, through their ecological habitats. What's interesting is that there's no homoplasies found in these two mammals groups, that they are just completely convergent evolution, which makes it very interesting and very, very cool. So in conclusion, we talked about the mammals, how they are found in the fossil record by their skull and by their teeth. And there's three groups of mammals: the monotremes, which give birth to egg-laying, or they are egg-laying, and the marsupials, which give live birth, but their young are so underdeveloped that they have to stay attached to the mother for a while, and the placentals, which have very highly developed young. And then the radiation of marsupials and placentals. So you just have to know the placental difference between the marsupials and the placentals, and that because marsupials are not as well adapted to the environment, they're not as radiated as much. And you see way more placentals on the earth. You see 99% placentals. And so I think that's just super important to understand. And the splitting of Gondwana and Laurasia, and where these two mammalian orders they went to, that the marsupials stayed on Gondwana and the placentals went up into Laurasia. And then to finish this up, why is it so important to study all of this? Because it helps us understand how evolution works. It's just such an interesting convergence that it's really important for us to understand that natural selection can work in convergence in such a high capacity. And also to understand more about ecological niches and how important they are and how they affect a species. And also because mammalian evolution is hardly studied. It is not very well known about. There's not very many fossils in the record, and we just don't really know much about it. So it's important to study marsupial and mammalian evolution, or placental evolution, so that we can understand where we came from and kind of what it's all about. And that's about it. And here's my references. And okay, and that's it for today.